6.4, more on the conditional. The conditional can be written in several ways other than if P, then Q. In fact, there's a whole bunch of different ways that it can be written, and it's basically the same thing. I see 1, 2, 3, 4, 5, 6, 7, 8, 9. All of those things mean the same thing as if P, then Q. Think about how the English language works. It would be pretty boring if we worded things the same way every single time. So we can mix it up. The language will be mixed up, but all 9 of those things mean the same thing. The translation of if P, then Q into these various word forms does not in any way depend on the truth or falsity of this. All right. So this is true. All these things are the same regardless of whether the overall statement is true or false. Example 1, write the statements in 8 equivalent ways. If you call, then I will answer. So we're just using that chart from the previous page, and we're going to write it in 9 equivalent ways, right? Or 8 equivalent ways to if you call, then I will answer. So the first way said, if you call, I will answer. We literally just took out the then. You calling implies I will answer. Number 3, you will call only if I'll answer. Number 4, I'll answer when you call. Number 5, you calling is sufficient for me to answer. And you look at some of these and you're like, well, there's no way I would ever speak that way. And you and I might not speak that way, but it doesn't matter. Someone might speak that way, or someone might write it that way in a book or whatever. All of these still, they're the same basic idea. Number 6. The answering is necessary for you calling. Seven, excuse me. All who call will be answered. And number 8, I will answer if you call. All right, so we have 9 different ways of saying the exact same thing, but clearly we prefer that. If you call, then I will answer is the one we use the most, we see the most, we would rather have those, but all the other ones mean the same thing. Number 2, write each statement in the form of if P, then Q. It says, possession of a valid ID card is necessary for admission. So what I would do on a problem like this is I would try to match it up with which one it is. it looks like this one, right? Is necessary for. Possession of a valid ID card is necessary for admission. So if you look back, you look at number 6 and notice the original statement where they're kind of switched. Answering is necessary for calling. It's backwards. So in order to do that same kind of swap, we swap them. Okay. Swap the first part and the second part. So we can write it like this. If you gain admission, sometimes we have to play around with the language just to make it make sense. If you gain admission, then you possess a valid ID card. We might want to write down here that this was number 6. So part B, you should use this door only if there is an emergency. I would go back and look. It says only if. It looks like this one, number 3. You'll call only if I'll answer. So notice again, compare number 3 to the original. Did I switch them around? It doesn't look like I switched them around. It's this one first. Only if this one. So don't switch them around. Okay. If you use this door, then there is an emergency. That was number 3 above. Next one, 2C. All who are weary can come and rest. All who are weary can come and rest. Looks like number 7. All who call will be answered. Again, I think about, do I switch them around? It doesn't look like I switch them around. All who call will be answered. Don't switch it. Don't switch the things around. This is number 7, and we're not going to switch them around. Okay. We're not going to switch those things around. If you are weary, then you can come and rest. Kind of tricky. You got to really think about it. You got to compare it back to the table or whatever. Really think about how the language works. Let's move on. Number 3. Let R represent a triangle as a right triangle, and S represent the sum of the squares of the two sides equals the square of the hypotenuse. Write each statement in symbols. So it says a triangle is a right triangle. Well, that was R. If the sum of the squares of the two sides equals the square of the hypotenuse, that was where they want that to be, S. So, it says, if you symbolize that, it literally just says R if S, right? R if S, R if S. Well, that if is still a word, so we haven't technically done it in symbols, okay? R if S, R if S. Go back and look. Which one is that one? And number 3? No, 3 says only if. Number 8, I will answer if you call. It's this one. It's the one. It's number 8. Okay. And number 8 looks like it switches the two things. So if this is number 8, then we're just going to switch them and say this. Kind of tricky. Have to think about it. So then part B. A triangle is a right triangle if only if that was. Oh, wait. No, sorry. A triangle is a right triangle. That was R. And then only if the sum, blah, 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 blah. That was S. So this problem says R only if S. R only if S. So again, go back to that chart. Only if was this one. Number 3, you'll call only if I'll answer. We did not switch it this time. The only if one does not switch, so we can just write it down without switching, like so. All right. This is important. We're talking about converse, inverse, and contrapositive. You might remember this from geometry class. It's the same concept. We had this in geometry, but the converse switches the antecedent and consequent. That means the first part and the second part. The inverse negates the antecedent and consequent. The contrapositive switches and negates the antecedent and the consequent. So the first part and the second part. All right, so converse switches, inverse negates, contrapositive switches and negates. Probably want to have that pretty close to memorized. So with symbols, the original statement might look like if P then Q. Notice the converse, we switch, and the inverse, we're going to negate. And the contrapositive, we're going to do both. We're going to switch and negate. And do you understand what I mean by that? Like, we started with P on the left and Q on the right. Well, we switch them, so Q and P are switched, but we also have to negate them. The contrapositive does both of the things. It switches them and it negates them. Number 4. Find the converse, inverse, and contrapositive of the following statement. If today is Monday, then we have to put out the garbage. I think it's almost always easier to think about the symbols rather than the words. If today is Monday, then we have to put out the garbage. Think about it as symbols. So then in symbols, your converse is going to switch the two things. Your inverse is going to negate the two things, and the contrapositive is going to do both. It's going to switch them and negate them. So if you can get the symbols, then you can just put it back into language, put it back into words. So the converse is going to say something like, if we have to put out the garbage, then today is Monday. And I get it. You don't necessarily need to do the symbols to be able to switch them like that. So I understand you're probably thinking, well, I would skip the symbol step, but I think it's so much easier if you're looking at the symbols than if you're looking at the words. Inverse, you need to negate both of the statements, the first part and the second part. If today isn't Monday, then we don't have to put out the garbage. Contrapositive, we switch and negate. Switch and negate if we don't have to put out the garbage. Then today is not Monday. Now, when we talk about truth values, you're supposed to notice something. You're supposed to notice that the original statement has the exact same truth values as the contrapositive. T, F, T, T. Those truth values for the original would be the exact same as the contrapositive. So in other words, those two statements are equivalent. If I said this statement and you said this statement, they're the same thing. They have the same truth values. And likewise, the converse and the inverse are also equivalent. So T, T, F, T, those two would be saying the same thing. The original and the contrapositive would be saying the same thing. Number 5. Consider the following statement. If Kathy is a cat, then Kathy is a mammal. So again, we want to think about symbols. If Kathy is a cat, then Kathy is a mammal. So the converse switches them. The inverse negates them. And the contrapositive does both, switches and negates. And I'm gonna skip all of the writing and stuff. Technically, since this is a word problem, your answer would be in words, but we could do that. The first one, part A, says if Kathy is a mammal, then she is a cat. I mean, you can write that on your own, but we literally just did an example like this with all this writing, so I'm gonna skip the writing for that one. Let's move on. The biconditional. Think about what bi means. Okay, the biconditional is written like this. And it's kind of weird because it's an if-then statement, but it works both ways. All right. We would read this as P if and only if Q. That's how you'd read it. That's how you say it. When you see this symbol, the double-sided arrow, it means if and only if. It's the biconditional. It's like a conditional that works both ways. You can shortcut the language sometimes like this. IFF means if and only if. If you ever see IFF means if and only if, and it's talking about that biconditional. But when we say it, we're going to read it as P if and only if Q. And so the biconditional oops, biconditional. It's like a conditional that works both ways. So if you think about it, it would be the same thing as saying if P then Q, and also if Q then P. You're doing both of them. And so in order to construct a truth table for this, we're actually going to show this and statement. We want a truth table for the biconditional. We've got two components. So remember how we construct it. In order to get to the biconditional, we don't know the truth values of the biconditional yet, so we're going to kind of jump through a hoop and do this. Which you should know how to do that. We're going to do that and statement. So if P then Q, and so like P is true and Q is true, so true implies true is true. True implies false is false. False implies true is true. False implies false is true. So we know that conditional statement is only false when it goes T to F. But now we go the other way. Q, let's do it this way. Here's the row for Q, or the column for Q, and here's the column for P. True implies true is true. False implies true is true. True implies false is false. False implies false is true. So now we got to do the and statement. True and true is true. False and true is false. True and false is false. True and true is true. So that's where we're at. TFFT. Equivalent. Now, something to take away from this. Something to take away from this is the overall truth value is going to be true when these two things are the same. True, true, false, false. If the original two statements are the same thing, it's going to be true. If the original two statements are opposites, it's going to be false. So that's something that's good to remember. Only true when P and Q have the same truth value. Last slide, true or false? Washington was the first president if and only if Adams was the second president. What I would do is I would symbolize this. See this if and only if? That's the biconditional. So let's symbolize Washington was the first president if and only if Adams was the second president. So break it down. True or false? Washington was the first president. That's true. Okay. True or false? Adams was the second president. Also true. And so we've got, true if and only if true. Notice what we just said the last time. If they're both the same, true and true, this overall statement is going to be true. So that overall statement, Washington was the first president if and only if Adams was the second president, true statement. Part B, Alaska is one of the original 13 colonies if and only if kangaroos can fly. So is that statement true or false? Well, your gut tells you it's false. Alaska is one of the original 13 colonies. Well, no, it's not. If and only if kangaroos can fly. Well, no, they can't. Think about this. Break it down into its parts. True or false? Alaska is one of the original 13 colonies. False. True or false? Kangaroos can fly. Also false. In the biconditional, when those two components have the same truth value, then the overall truth value is true. So even though this statement seems like a lot of nonsense, technically, logically, that's a true statement. Part C, 2 plus 2 equals 4, if and only if 7 is greater than 10. Well, this statement is true. If and only if this statement, that's false. When they're different, the overall statement is false. The overall biconditional statement is false. And last, we have a summary of basic truth tables. We already know a lot of this. A lot of this is review. The negation of P has the truth value opposite of P. We knew that. The conjunction means and, so it's only true when both of them are true. The disjunction is or. It's false only when both of them are false, meaning false or false. The conditional is false only when P is true and Q is false, like this. The biconditional is what we just learned, is true only when P and Q have the same truth value. So true if and only if true, false only if, or if and only if false.